Hello everyone. So in this video I will show you how you can write the Fourier transform of rectangular function, sinc function, triangular function and the sinc square function without any error and very quickly. So for that you need to remember these four standard function. First one is the rectangular function, and second is the sinc function, third is triangular function, and the last one is the sinc square function. And we all know that the Fourier transform of rectangular function is a sinc function, and the Fourier transform of sinc function is a rectangular function. Similarly, Fourier transform of triangular function is a sinc square function, and Fourier transform of sinc square function is a triangular function. So another thing is that in this case all the function are written in time domain only, but in case of frequency domain you have to replace the time t by f, that is the frequency f. Suppose a rectangular function is given like a by mod a rectangular t by a in time domain, then its Fourier transform will be a sinc af, this function only, right? Similarly, if this function or the function of this format is given, in that case your Fourier transform will be a rectangular function, that is the Fourier transform of sinc function is a rectangular function. You have to just replace this t by f. Okay, let us see an example. Suppose a function say 5 sinc 2t is given, that is the function, the time domain is a sinc function, this one. So your Fourier transform will be a rectangular function of the format will be a by mod a rectangular f by a. So this one, and I have just replaced this t by f. So now you need to find out this value of capital A as small a, right? So here the function is 5 sinc 2t, so this one, this function, so your value of capital A is 5 and value of small a is 2, so you can just replace over here. You can get the Fourier transform as 5 by 2 rectangular a by 2. So if you want to find out this transform in omega domain, in that case it will be simply 5 by 2 rectangular, just multiply 2 pi in both side, numerator and denominator, that will be this will be 4 pi, and so this will be 2.5 rectangular omega by 4 pi. Now let us take another example, say 10 rectangular 3t, right? 10 rectangular t by 3, this is standard format. So if you compare this function with this function, so you will get a by mod a, that is equals to 10, and your a is 3, so that is small a. So capital A equals to 10 into mod of small a, that is equals to 3, that is equals to 30. So this is in time domain, the rectangular function. The Fourier transform will be the sinc function, and the format will be this Fourier transform, that will be a sinc af, not t, af, this one. Okay, so your capital A is 30 sinc, small a is 3f. Now in omega domain this will be 30 sinc, it will be 3 2 pi f by 2 pi f, 2 pi, not 2 pi f. So this will be 30 sinc 3 by 2 pi omega. Okay, so this will be in omega domain. Now suppose a triangular function is given, and we know that for triangular function the Fourier transform is sinc square function, and similarly for sinc square function the Fourier transform is triangular function. Suppose a function is given as say 20 triangular say t by 5, right? So if you compare this function, this is equals to your xt, that is in time domain. If you compare this function with this function, standard function, so you will get a by mod a, that is equals to how much? 20, and your small a is 5. So your capital A is 5 into 20, that is equals to 100. So the Fourier transform of triangular function, we know the sinc square function. So the Fourier transform, it will be, Fourier transform is a sinc square, we have to replace this t by f. Okay, so this will be a f. So your value of a is 100 sinc square, a is 5 5f. So this is the Fourier transform of a triangular function. You can easily write. Similarly, you can find out if the in time domain the function is given as a sinc square function, that means this one, you can easily find the in frequency domain the triangular function. A small important thing is that for the rectangular function, that is rectangular t by a format, and for the triangular function this is also t by a format, but here it is minus t by 2 to plus t by 2. This the graph is this is from minus t by 2 plus t by 2, and for triangular function it is from minus a to plus a, sorry, it minus a by 2 to plus a by 2, and this is for triangular function this is from minus a to plus a. So by this formula you can also calculate the inverse Fourier transform also. Suppose a function is given as say 15 rectangular 3f. So you can write it as 15 rectangular a by 1 by 3. So because to make the standard form, right? So this is the format. So for the frequency domain you have to replace, you have to compare this function by replacing this t by f, so this one. So your a is 1 by 3, and that is small a, and capital A is sorry, not capital A, this will be this one, capital A by mod a, that is equals to 15. So your capital A is 15 into mod a is 1 by 3, that is equals to 5. So capital A is equals to 5 and small a equals to 1 by 3. So we know for the rectangular function it is in frequency domain in this case. So in time domain it will be a sinc function, inverse Fourier transform. So it will be sinc function. So the function will be that is this is x of f, and the inverse Fourier transform, that will be x of t, that is a sinc at, right? So this will be a is 5 sinc, and small a is 1 by 3 t. So this is 5 sinc t by 3. This is the Fourier transform, inverse Fourier transform of this function. Suppose the function is given as x of omega equals to 15 rectangular omega by 3. So you can write it as 15 rectangular omega is 2 pi f by 3. So this is equals to 15 rectangular f divided by 3 by 2 pi, right? So if you compare this function with this one, and for that, in order to compare, you just have to replace this t by f and then compare. So your a by mod a, this one, this part, that is equals to 15, and your small a, that is equals to 3 by 2 pi, right? 3 by 2 pi. So your capital A equals to 15 into mod a, mod of small a, that is equal to 3 by 2 pi. So this will be your 45 divided by 2 pi. So the function is in frequency domain. So the in time domain it will be sinc function, because in frequency domain this is rectangular function. So the function will be the inverse Fourier transform. This will be a sinc at, this function, right? So we know the value of a, that is equals to 45 by 2 pi sinc, and a small is 3 by 2 pi into t. So this is the Fourier inverse Fourier transform of the function x of omega. So without any error you can write the Fourier transform, inverse Fourier transform of x of omega.